If you want more coding fun, hit like, subscribe, and let's get started on the next tutorial. In this video, we will learn about depth first search. Depth first search, DFS, is a way to explore all the possible paths in a graph or tree by starting at one point and exploring as far as possible along each branch before backtracking. Imagine you are in a maze, and you just pick a path and follow it until you hit a dead end. If you hit a dead end, you go back and try another path. That's pretty much how DFS works. At each step, DFS picks a node, explores as far as it can down one path, and only backtracks when it has no more options. This makes DFS good for problems where you need to explore all possibilities in a deep manner, like solving puzzles or finding paths in a network. Let's break down the process. You start with an initial node, mark it as visited, and move to one of its neighbors. You keep doing this until you reach a dead end or a node with no unvisited neighbors. Then you backtrack and explore other nodes. The algorithm can be implemented using a stack to keep track of nodes that you still need to visit. The stack keeps track of where you have been and helps you backtrack when needed. Now, let us look at the code for DFS. Define the graph as an adjacency list. This function performs depth-first search. A set to keep track of visited nodes. A stack to manage the nodes to visit next. Pop the last node from the stack to explore. If this node has not been visited, mark the node as visited. For demonstration, print the node being visited. Add the neighbors of the current node to the stack. We add them in reverse order, so we can explore the leftmost first. Run the DFS starting from node. Now run our code. Do you want to become a coding pro? Then hit that subscribe button and like this video right now. I'm here to give you the best coding tutorials, and I don't want you to miss any of the fun. By subscribing, you're not just supporting the channel, you're investing in your coding future. Let's build something awesome together.